Hello students, in this video we will be discussing very important questions of relation and functions. So first of all we will be discussing the 1 mark questions in this video, okay? And these questions will be very important. You can go through it and you can do same type of questions after watching the video, okay? So let's see the first question. So the first question is write the smallest reflexive relation on the set containing A, B, C, D. Okay, so this sets contain elements A, B, C, D. 4 elements are there. Okay, so I want to write the smallest reflexive relation on that set. Okay, so if I write the set to be A, okay, I am taking A is equal to the given set. Okay, so the smallest reflexive relation, in order a relation to be reflexive, for all the elements I will need A1 A, B B, C C, D D. All these elements must be in the set, in the relation. I mean to say that in that relation all these elements must be there, then only it will be a reflexive relation. Okay, so these elements must be there. Along with that, any other elements will be also there, but in order to form smallest reflexive relation, if they are there, then it's sufficient, isn't it? So the smallest reflexive relation on set A is, I am denoting it by R only, will be A comma A, B comma B, likewise C comma C, D comma D. So the relation R, which will contain A comma A, B comma B, C comma C and D comma D, will be the relation which will be reflexive, and it will be the smallest reflexive relation. Okay, so in this way we can write the smallest reflexive relation on the given set. Let's see the next question, that is, state the reason for the relation R in the set 1 to 3 given by R is equal to, we have 2 elements in the relation R, 1 2, ordered pair 1 2 and 2 1. Okay, so we'll have to state a reason why it is not transitive. Okay, so let me take the given set to be A. Okay, and we have the given relation is 1 2 2 1. So here we can see that 1 2 belongs to R and 2 1 is belonging to the relation R, but 1 comma 1 does not belong to R. So we know the condition for transitive. If xy lies in R and yz lies in R, then xz must lie in R, then only R will be transitive. But here I can see that 1 comma 1 does not lie in R. We don't have 1 comma 1 ordered pair in the relation R. Okay, so it will not be, for this reason only, it will not be transitive. Therefore R is not transitive. So I have written the reason here. Okay, so these questions are for 1 mark only. So first of all I am doing some questions, important questions, which carries 1 mark. Okay, so let's see the next question. So next question is, if A is equal to 0 1 3, it's given 0 1 3 in the set A, what is the number of relations on A? Okay, so we want to find the number of relations. So a relation, if it is from A to B, a relation from A to B, in this case the number of relation is given by the formula 2 to the power number of elements of A into number of elements of B. It's given like this. Okay, if the relation is from A to B, then total number of relations will be 2 to the power number of elements of A into number of elements of B, that is cardinality of A into cardinality of B. Okay, so here in this case our relation is on a set, isn't it? On a set means the relation is going from A to A, so we are defining a relation from A to A. Okay, so here we have the set given A is equal to 0 1 3. Okay, so therefore the relation is defined on A, so it is going from A to A. So relation we are defining from A to A. Okay, so number of relations on A will be equal to 2 to the power NA. In place of B I have A only, isn't it? So NA only. So its formula is what? Now 2 to the power cardinality of A into cardinality of B. So here A, in place of A I have A only, in place of B I have A. That's why in both the cases I am writing A only. So you will do 2 to the power, cardinality of A is how much? 3 here. Okay, cardinality of A is 3, so it will be 3 into 3, so I will get 2 to the power 9. Okay, so next question you see, next question is let A is, again it's given 1 2 3. Okay, for x y belongs to A, let x is related to y, x is related to y if and only if x is greater than y. Okay, so according to question what it is given, let me write here. A is given 1 2 3. Okay, according to question the relation R will contain those elements such that x is greater than y. Okay, here x y will lie in A only. Okay, so the relation R will contain those elements, those ordered pairs which will satisfy this condition, x is greater than y. Okay, so and this relation will be obviously a subset of A cross A only. So directly also you can write, or you can find A cross A. A cross A will be what? 1 2 3 cross here 1 2 3. Okay, so I will get 1 1 1 2 1 3, likewise 2 1 2 2 2 3. I will get 3 1 3 2 3 3. I will get. So in A cross A, Cartesian product of A and A cross A will be this one. Okay, now therefore R will be what? In R what is what type of elements are there? X comma y such that x is greater than y. So you will have to choose those elements whose x coordinate is greater than the y coordinate. Okay, so that is the domain is greater than the range. Domain element is greater than the range element. Like that also I can think. Now you search like that. So first of all I can write 2 1 element. Here I can see that x is greater than y. Similarly I can write 3 1, and similarly I can write 3 2. So these are the 3 elements where the first coordinate is greater than the second coordinate. If I will see in an ordered pair. Okay, so this is greater than this, x is greater than y, x is greater than y, x is greater than y. So this is the required relation which is asked in the question, and it is a subset of, obviously it is a subset of A cross A only, isn't it? So this is done. So let's see the next question. Next question is if A is 1, 2, 3, 4. 4 elements are given in A, okay, and in the set B I have 2 elements 5, 6. Then write the total number of onto functions from A to B, okay. So as you know, I have discussed in the last video about how to find a number of onto functions, okay. So I will be using that. Now you see here, I can see that the cardinality of A set is 4 and the cardinality of which I took and considered it to be P, okay. So I am writing here P, and cardinality of let me write like this, P is equal like this, and cardinality of B set is 2, okay. So whenever the cardinality of A is greater than cardinality of B, then 1 functions are not possible, but onto functions are possible. So here we can see that P is greater than Q. So the total number of onto functions will be equal to, the formula was first of all, total number of functions we'll have to subtract, is that from total number of functions we'll have to subtract the remaining things. So total number of function is cardinality of B to the power cardinality of A minus, the formula was what, QC1 Q minus 1 to the power P, okay. Likewise I can write the next term like this, QC2 Q minus 2 to the power P. It will go on like this. So what is the value of Q? It is 2. Value of P is 4. Minus, here it will be 2C1 2 minus 1 to the power 4. Here if I will write the next term, it will be what, 2C2 2 minus 2, it will be 0 only. So I am not writing the next term, we can stop here only. So I am getting this only, okay. So it will be how much, 2 to the power 4 is 16 minus, here 2 minus 1 will be 1, 1 to the power 4 will be 1, 2C 1 will be 2, is that it? So I am writing here 2, so I am getting here 14. So the total number of onto functions from A to B in this case will be 14. So how we have found? We have found by using the formula, okay. Without the formula it will be difficult, so you can keep the formula in mind, okay. These formulas will be useful, okay, in further studies also, not only in class 12, in higher studies also, like if we give exams for SET, CS, CSIR, NET, okay, there also this type of questions are asked. So you can keep in mind these formulas. Let us see the next question. Next question is what? Set A is given, set B is given. We'll have to find the number of 1 functions from A to B, okay. So here we can see that cardinality of A is 4 and cardinality of B, number of elements of B is 3, okay. So here I see that cardinality of A is greater than cardinality of B, and therefore whenever the set A is greater than set B, at that time 1 functions are not possible. I have discussed this in the last video, okay. So therefore what I can write, the total number, therefore the total number of 1 functions will be how much? It will be a big 0, okay. It will be 0. Next question is set A is given A, B, C, okay, and set B -2, -1, 0, 1, 2. Okay. So we are dealing with number of elements in A and number of elements in B only. Okay. So you know that in order to find the number of 1 functions or 1 functions, we will be dealing with number of elements of A and number of elements of B only. So here we can see that number of elements of A is how much? 3, and number of elements of B, cardinality of B, is 5. So here I have P is less than Q, means cardinality of A is less than cardinality of B. So whenever the set A is smaller than set B, 1 functions are possible. 1 functions are possible. So therefore total number of 1 functions is equal to, we know the formula, it is Q P P, isn't it? So what we have Q is how much? 5 P, it will be 3. So just use the formula factorial 5 by factorial 5 minus 3. It will be how much? It will be 5 into 4 into 3 factorial 2 by factorial 2. So I will be getting 60. So there will be 60 1 functions from A to B. Okay. Next, let us see this question. Here 2 functions are given, f and g. Okay, both are going from R to R. Okay, so they are defined by fx is equal to modulus of x and gx is equal to greatest integer of x. So greatest integer function, you know, greatest integer function means you'll have to take the greatest integer less than or equal to x. Okay, so we'll have to find f or g of 5.75 and g or f of minus root 5. Okay, so let us write the given functions. Okay, we have given that fx is a function from R to R, which is defined by fx is equal to mod x, and g is a function from R to R, which is defined by gx is equal to greatest integer of x. Okay, so let us find the first one. Okay, so first one is what? Now f or g of 5.75 I want to find. So first of all, let me write like this, f of g of 5.75. okay, so you know the composition of f, g and f. If I am writing like this, f of g of x like this, then it will be f of g of x. So it is from the definition. This is the definition. Okay, so by looking at that only I am doing it. Okay, so let us do it. So how g is defined? G is defined, gx is equal to greatest integer of x. So it will be greatest integer of 5.75. So greatest integer of 5.75 will be what? It will be the least integer, less than that. It will be the integer less than that number. So just less than this number, what is the integer? It is 5, isn't it? So I am writing here 5. Greatest integer of this will be 5. Now f of 5 will be what? F of 5 will be, if f of x is mod x, then f of 5 will be mod 5, modulus of 5, and modulus of 5 is what? 5 only. Okay, again we have g of f of minus root 5 will be what? G of f of minus root 5. So first of all we will have to apply the f function. Fx means mod of x. So f of minus root 5 will be root of minus, mod of minus root 5. So it will be what? G of positive root 5, isn't it? So root 5 actually it is what? It is 2 point something, isn't it? So greatest integer of 2 point something will be how much? G is defined like that, isn't it? Gx is equal to greatest integer of x. So g of x, think that this is x. So greatest integer of x. So greatest integer of 2 point something will be what? 2 only. So this is the answer. So next question is if the function f is given by this, okay? F is given like this, means that f of 1 is 5, f of 2 is 6, f of 3 is 4. It's given like that. From set A 1 to 3 to set B is invertible. It's given that f is invertible. We'll have to find the set B. So it's very clear that if f is invertible, the set B will be 5, 6, 4 only. Okay, but let me do in detail. Okay, so f is given here 1, 5, 2, 6, 3, 4 like that, isn't it? So by looking at this, I can write domain of f is what? Domain of f will be the first elements will be the domain 1, 2, 3. Okay, so it is A only. Yes, A will be the domain, and range will be how much? Range of f will be how much? Here it will be 4 is there, 5 is there, 6 is there. 4, 5, 6 will be the range. Okay, now you see it's given that f is, since f is invertible, okay, f is invertible. If f is invertible, then we know that f is invertible only if f is 1, 1 and on 2. Okay, so I can write f is 1, 1 and on 2, and since f is on 2, therefore codomain will be equal to range of f, isn't it? On 2 means what? Whenever the function, in a function, the codomain is equal to range of f, then only we can tell that it is on 2, isn't it? So that is the condition. So I am writing on 2 is there, f is on 2, that's why codomain will be equal to range of f. So codomain is what? Actually f is going from A to B, so codomain is B, isn't it? F is going from A to B, so B is the codomain. So codomain is B, and range of f is what? 4, 5, 6. Okay, so range of f is 4, 5. So directly also we can write from here, directly we can write the answer B will be 4, 5, 6 because it is invertible. Okay, but those who don't know how to do it, if you will go like this, you will understand the thing why we are getting the set B is equal to 4, 5, 6. But whoever knows the concept clearly, you can write it directly also. Okay, next question is if f from R to R be defined by, okay, defined by fx is equal to 3 minus x cube whole to the power 1 by 3, then we will have to find the value of f of x. Okay, so we have f from R to R defined by f of x is equal to 3 minus x cube whole to the power 1 by 3. Okay, I want to find f of x. Okay, f of x. So f of x will be f of x. So what is fx? Fx is nothing but this is the function, so it will be 3 minus x cube whole to the power 1 by 3. Okay, so fx, in place of fx I am putting this. Now here I have a function f, inside whatever is there I will think this is x. Okay, so in fx I will put wherever x is there, I will put this. So now what I will have to think, f of x, the function is what? F of x is 3 minus x cube to the power 1 by 3, isn't it? So in place of x, what I have now? This whole expression is there, and I will consider this to be the value of x, and I will put it here. So it will be 3 minus, this is x now, this is x, okay, this is x, whole value is x, x to the power what? 3, whole to the power 1 by 3 is there. Okay, so what I will get? I will get 3 minus this 1 by 3 and 3 will get cancelled. I will be left with 3 minus x cube whole to the power 1 by 3 I will be left. So it will be 3 minus 3 plus x cube whole to the power 1 by 3. So I will get x cube whole to the power 1 by 3. So this is x. So this will be the answer. So while doing this type of problems, you look at the function what you are doing. After this, I have the function f again. So whatever will be inside those things I will consider x and I will put in the function of fx. So f is there, so fx I am putting in place of x. I have this, so in place of x I am putting this expression. Okay, so in that way you can do it. This type of questions comes, okay, in exam, very important. It may come for 1 mark only, but it's important. Everywhere this type of question, every year this type of questions comes. Okay, so practice this type of questions more. So next question, let us see a similar type of question. Okay, so next question, the function f from r to r given, and it is defined by fx is equal to 3x square minus 5, and g from r to r is given and it is defined by gx is equal to x divided by x square plus 1. We want to find the value of g of x. Okay, g of f. Okay, g of f of x. Okay, so here we have fx. F is defined by fx is equal to 3x square minus 5, and g is defined by gx is equal to x divided by x square plus 1. Okay, so now I want to find g of f. Okay, so in order to find it, I will have to take an element x. Okay, now g of f of x, I can write it and it will be equal to fx. I have the function 3x square minus 5. Now I will have to do what? G function, isn't it? So whatever is inside I will consider it as x, and wherever it is x there in the function gx, there I will be putting this value. In place of x, here I will be putting this expression. Okay, so gx is defined like this. So x divided by what? I have x divided by x square plus 1, isn't it? G function is defined like this. So wherever x is there, I will have to write this. So 3x square minus 5, and also 3x square minus 5. Okay, so let me do it. I will get here 3x square minus 5 divided by a minus b whole square formula. You apply it, it will be 9x to the power 4. It will be minus 30x square plus 25 plus 1. So it will be 3x square minus 5 divided by 9x to the power 4 minus 30x square plus 26. So this will be the answer. This type of questions are important. Again I am telling. So while doing, do it nicely and concentrate what we are doing on whatever we are doing. Okay, so concentrate whenever we have an expression and we are applying the function. So whenever a function is there, inside it an expression is there, you'll have to consider x and put it in that function only. So that thing is very important for you. Okay, so these were some important 1 mark questions which is very important for your board exam. Okay, and in the next video I will be discussing more problems related to relation functions. Okay, to chapter relation function, and those problems will be for 4 marks or 6 marks like that. So let's see in the next class. Okay, till then, bye, take care.